Okay, as discussed earlier, the rate in improvement in secondary storage performance has been considerably less than the rate for processors and main memory. So kalau kita tengok, the improvement of secondary storage macam hard disk tu, dia sangat slow berbanding processor dengan main memory tu. Okay, so this become the main focus of concern in improving the overall computer system performance. So, as in other areas of computer performance, these storage designers recognize that if one component can only be pushed so far, additional gain in performance are to be had by using multiple parallel components. In this view, actually kalau kita tengok dekat dalam hard disk tu tak banyak improvement yang dia boleh buat daripada hard disk drive tu. Jadi apa yang dicadangkan adalah the designer propose a parallel disk, okay, parallel component using a multiple parallel component, which in the case of this storage dia akan jadi array of disk that operate independently and in parallel. So kita ada multiple disk, okay, yang kita akan nampak sebagai satu logical drive. Okay, satu logical drive yang mana kita akan handle in parallel lah, as long as the data required reside on a separate disk. Okay, so further, a single I/O request can be executed in parallel if the block of data can be accessed and distributed across multiple disks. Jadi, this come with the concept of RAID. Okay, maknanya kalau kita tengok ni, dia orang propose concept RAID tu iaitu redundant array of independent disk, ataupun kita sebut ada nama lain dia adalah dia kata redundant array of inexpensive disk. Okay, so we have a 6 levels in common use. Kalau disebut level tu, it's not a hierarchy. Contohnya level 0 tu paling rendah, level 1 tu paling ni. No, it's not. So dia sebut level ni adalah in terms of the design itself lah, the design of the disk tu sebenarnya. Okay, so what is RAID? RAID is a set of physical disks view as a single logical drive by the operating system. So the data are distributed across the physical drive of an array in a scheme known as striping, described after this. And then it can use redundant capacity to store parity information, which guarantee the data recoverability in case of a disk failure lah. So that's why kita panggil dia sebagai redundant. Okay, redundant. So we have 7 levels. Okay, 7 levels. Start from level 0 until level 6. Okay, so there is additional level that has been defined by some researchers and also companies. Tapi yang 7 levels ni adalah yang kita sebut sebagai universal lah. Universal level. Yang diorang persetujui sebenarnya. So we have a category with the name of the level. Category ni maksudnya dia punya nama dia. And then this is the level. So kita ada level kosong yang kita panggil sebagai striping. 1 as a mirroring. 2 dengan 3. Level 2 dengan 3 adalah parallel access. 4, 5, 6 adalah independent access. Okay, so table ni adalah it's like a guide. Okay, or a features of the RAID levels tu sebenarnya. Okay. RAID level kosong. Okay, kalau kita tengok kat sini. Okay, sebelum saya terangkan pasal RAID ni sebenarnya, kita kena tahu the characteristic, 3 common characteristic of RAID. Yang ni adalah 3 common characteristic. So, awak boleh tanda dekat dalam buku. So, this is the 3 common, sorry. Ni adalah nombor karakteristik 1, 2, this is 3. Yang ni adalah bawah karakteristik 3. Ni, guarantee ni. Sepatutnya dia bersambung lah. So, setiap satu design ataupun kita kata level tu must follow the karakteristik ni. Okay, karakteristik 1, 2 dan 3 sebenarnya. Okay. So, kalau kita tengok kat sini, this is the design of a RAID level 0. Kita panggil dia sebagai striping yang mana dia ada stripe 0, 1, 2, 3, 4, 5, 6. Kalau tengok kat sini, there is no redundancy. Macam mana orang nak tahu dia ada redundancy ke tak? Kalau kita tengok kat sini, semuanya number dia unik. Strip 0, 1, 2, 3, 4, 5, 6. So, tak ada redundancy. Dia tak ada pun 2 strip kosong dekat dalam ni. 2 strip 1, 2 strip 2 ke apa ke. So, dia tak ada konsep redundancy. So, karakteristik yang ketiga tu dia tak ada. Okay. So, the user and system data are distributed across all of the disk in the array. So, kalau kita ada user data ataupun system data, okay, dia distributed. Okay, dia distribute across all the disk. Okay. So, the striping concept ataupun kita kata mechanism menggunakan round robin. Round robin itu bermaksud kita akan masuk satu untuk engkau, satu untuk aku, satu untuk engkau, satu untuk aku. So, that kind of round robin. Okay. So, semua kena masuk dulu. Semua disk kena masuk, kena pecahkan kepada strip. Okay. And then baru start balik pada disk yang kosong tu lah. Okay. Disk yang pertama balik. Okay. Okay. The advantages ataupun kita kata the performance. Okay. So, they increase speed. Okay. They have increased speed. So, because of the multiple data request probably not on the same disk. Okay. So, sometimes what they request is not on the same disk. So, the disk seek is in parallel, which will reduce the I/O transfer time. Okay, so multiple request may be on a multiple strip. So that's why dia punya performance dia tinggi lah. Kita panggil very high large I/O data transfer capacity. So a set of data is likely to be striped across multiple disks. Okay, so the advantages is that the I/O performance is improved by spreading the I/O load across many channels and drive. No parity calculation overhead is involved. So disebabkan dia tak ada redundancy, dia tak ada buat parity calculation. So no parity calculation means that tak ada kerja tambahan yang dia kena buat. So it's a very simple design and very easy to implement. However, okay. So since dia tak ada redundancy, so the failure of just one drive will result in all data in an array being lost. Okay, disebabkan kita gunakan multiple disk which store different stripe. Okay, maknanya different data, different system data semua tu. So, once these two fail, so habis hilang. So, what type of application yang menggunakan RAID level 0? Kita gunakan video production and editing, image editing, pre-press application, and any application which require high bandwidth. Okay, level 1. Okay, level 1 yang kita panggil sebagai mirror. Okay, level 1 panggil sebagai mirror. Kalau kita tengok kat sini, okay, level 1 ni dia tak ada redundant. Okay, redundant means that dia tak simpan parity. Kita cari yang ada parity numbers, tak ada kan? Semuanya strip 0, strip 1, strip 2 saja kan? So, dia tak ada parity. Okay. So, bila dia tak ada parity, dia macam karakteristik dia lain sikit daripada RAID ni lah sebenarnya. Okay. Kalau macam RAID 1 ni, okay, dia different dengan level 2 sampai 6 yang seterusnya disebabkan dia tak ada redundancy. So, in this other RAID scheme, some form of parity calculation is used to introduce redundancy. Tapi, RAID 1, ada redundancy tapi special sikit dia punya scheme dia yang mana dia achieve by the simple expedient of duplicating all the data. Kalau kita tengok kat sini, this side and this side is the same. It's mirroring. Okay, it's mirroring. So each logical strip mapped to 2 separate physical disks. So every disk in the array has a mirror disk that contains the same data. Kalau kita tengok dekat situ. Okay, so a read request can be serviced by either of the 2 disks that contains the requested data. Okay. Whichever one involve the minimum seek time plus rotational latency. So it's quite fast because high performance lah sebenarnya. Kalau yang write request requires that both corresponding strips to be updated. So, this can be done in parallel. So, kalau katakan kita nak update pada strip 1 dan strip 1, kita boleh buat secara parallel. Cuma, the write performance is dictated by the slower of the two writes. Okay, yang mana satu yang paling last lah. The one that involve the larger seek time plus rotational latency. However, there is no write penalty with RAID 1. So RAID level 2 to 6 involve the use of parity bit. So therefore, when a single strip is updated, the array management software must first compute and update the parity bits as well as updating the actual strip in question. Okay, so that's how the read and write tu lah sebenarnya. So the recovery is very simple. Okay, so kalau lah katakan one disk down, kita akan swap the faulty disk and then re-mirror. Okay, so that's why kita panggil dia, yang ni kita panggil mirroring tu dia part of the redundancy. So disebabkan kita buat macam tu, there is no downtime. Okay. So advantages is that 100% redundancy of data means no rebuild is necessary in case of a disk failure. Dia just copy saja daripada replacement disk. Under certain circumstances, RAID 1 can sustain multiple simultaneous drive failures. Okay. And then simplest RAID storage subsystem design. This is very simple disebabkan dia just copy saja, dia mirror saja dengan apa yang original punya. Okay, but the disadvantage is that it require highest disk overhead of all RAID type. Maknanya of all level tu, dia yang paling tinggi sekali dia punya overhead, disk overhead. Okay, 100% inefficient, requires twice the disk space of the logical disk that it is support. Maknanya dia 2 times n, kita panggil macam tu kan. Sebab dia mirror, jadi dia membazir, dia kata macam tu. And also expensive. Okay, but masih lagi digunakan dalam accounting, payroll, financial or any application requiring very high availability. Benda yang melibatkan kewangan, diorang akan spend duit untuk gunakan this type of design RAID level lah. Macam tu. Okay, kita masuk RAID level 2. RAID level 2 and 3 make use of a parallel access technique. Dia nama dia parallel access technique. Okay, so in a parallel access array, all member disks participate in the execution of every I/O request. Typically, the spindles of the individual drives are synchronized so that each disk head is in the same position on each disk at any given time. So sama macam RAID level yang lain. So data striping is used. Cuma in this case, the strips are very small as a single byte or word. Okay. So with RAID 2, an error correcting code is calculated across corresponding bits on each data disk. So and then the bits of the code ni, kita punya parity bit tu lah ataupun error correcting code tu are stored in the corresponding bit position on multiple parity disks. Okay. So kalau kita tengok kat sini, ini adalah kita panggil bit stripe kita. So bit stripe, yang ni adalah data. Okay, data disk yang mana kita simpan secara bit stripe. So yang ni adalah kita punya parity disk. Kita panggil dia sebagai parity disk. Okay, so to represent yang ni. Okay, parity bit, data bits kita. Okay, so this is the parity bits for this one. And then F1B ni adalah yang ni. F2 ni adalah yang ni. Kita kata macam tu. So, for error correcting code ni, dia menggunakan Hamming code to correct single bit errors and detect double bit errors. Okay. It provide lots of redundancies. Okay. But expensive and not used. Okay. Not used disebabkan dia effective in an environment in which many disk errors will occur. So, given the high reliability of individual disk and disk drive, maksudnya sebab sekarang ni design of the disk tu dah more reliable. Jadi, rate tu ni macam overkill lah. Maksudnya terlebih sangat. Sepatutnya jadi macam tak gunalah. Kita tak gunakan sangat. Okay. Rate 3. Dia punya design dia organized similar as the rate 2. Okay. So only the difference is that rate 3 requires only a single redundant disk, no matter how large the disk array. Okay. So the rate 3 employs parallel access, sama macam rate 2 tu tadi. So with data distributed in small strips, instead of an error correcting code, a simple parity bit, okay, is computed for the set of individual bits in the same position, okay, on all of the data disk. Okay, so dia sama macam rate level 2 tadi, cuma parity disk adalah dekat dalam one disk array sahaja. Okay, on a single redundant disk. Okay, and then they use simple parity bit sahaja for the calculating the error correction code tu. Okay, so and then data on field drive can be reconstructed from surviving data and also the parity info. So in the event of this failure, all of the data are still available in what is referred to as a reduced mode. Okay, so that's why bila dia gunakan reduced mode campur dengan parity info, so kita dia boleh recover balik sebenarnya. Okay, read level 4. Okay, saya lupa nak cakap. Okay, performance untuk read level 3 kalau tengok dalam table, dia achieve very high data transfer rate. So disebabkan bila kita buat small strip ni, so dia punya transfer rate tu is very high. So any IO request will involve the parallel transfer data from all of the data disk. Untuk yang large transfer punya, performance improvement is especially noticeable. So on the other hand, only one IO request can be executed at a time. Okay, so untuk yang jenis transaction oriented environment, contoh macam banking, okay, so this type of environment, dia punya performance dia akan degraded lah, maksudnya dia suffer performance tu. Okay, so saya masuk rate level 4. Rate level 4 through 6, kan tadi yang saya sebut 4 hingga 6 tu, dia menggunakan independent access technique nama dia. So, kalau independent access technique ataupun independent access array, each member disk operate independently. So that kalau disk tu dia independent, kita panggil dia independent ni, setiap satu ni independent. So IO request tu kita boleh request serentak lah, maknanya on a different disk. Okay. So because of this, independent access array are more suitable for application that require high IO request rate and are relatively less suited for application that require high data transfer rate. Okay. So kalau kita tengok kat sini, strip tu adalah relatively large. So dia punya parity tu dia akan calculate a cost stripe on each disk. Okay, on each disk ni, so dia akan calculate daripada 0 sehingga 3. So and then ada parity dia. And then block 4 hingga 7 ada parity bit dia. And then block 8 hingga 11 parity bit untuk 8 tu. Kemudian dikalkulate lagi parity block 12 hingga 15. Macam tu So parity ni akan kita store dalam parity disk. Okay. So bila dia independent, okay, independent access technique, so kita sesuai untuk menggunakan high IO request rate. Okay, high IO request ni maksudnya macam server. Okay, server macam web server ke yang mana high request. So memang sesuai kalau kita gunakan level 4. But it is less suitable for applications that require high data transfer rate, yang mana dia memerlukan kalau macam jenis yang movie, okay, movie streaming, data streaming tu, so dia require high data transfer rate kan. Rate level 4 ni tak sesuai lah. Macam tu. Okay, rate level 5 pula, okay, is organized in a similar as RAID 4. The difference is that they distribute the parity strip across all these. Kalau kita tengok tadi yang sebelum RAID level 4, okay, parity disk, okay, parity bit simpan dalam satu parity disk kan. So what would happen is if the parity disk is corrupted, katakan tu kan, rosak. So dia tak nak jadi macam tu. Jadi dia buat, dia separate kan. Okay, dia distribute kan parity strip ni across all this. So contohnya untuk blok 0 sampai 3 simpan pada satu parity disk. And then 4, 5, 6 dia simpan pada disk yang lain. Parity 7, 8, 9 pada disk yang lain macam tu. And then 10 hingga 12. 8, 9, 10, 11 disimpan pada parity kat sini, bit kat sini. 12 hingga 15 kat sini. And then 16 hingga 19 kat sini. So apa yang berlaku adalah bila kita distribute parity strip across all drive, it avoids the potential of I/O bottleneck yang berlaku dekat dalam RAID 4. Okay, so the allocation for parity stripe ni kita gunakan round robin. Maknanya kalau dekat level tu, kita kata tu kan, dekat row tu, kita dah guna pada disk yang kelima, katakan ni yang disk kelima, katakan macam tu. So the next row adalah pada disk keempat. Macam tu, dia even. Okay, even allocation. So kita gunakan round robin. So it is commonly used in network server. Okay. So itu adalah untuk RAID level 5. Okay, next saya masuk dekat RAID level 6. Was introduced in a subsequent research by the Berkeley. So kalau dalam RAID 6 ni, two different parity calculation dia carry out and stored in a separate blocks on different disk. Okay, so ada dua parity calculation, satu P, satu Q dia buat macam tu So RAID 6 ni, okay, bila dia nak provide ataupun kita kata dia nak design tu, okay, dia punya calculation dia ataupun kita kata how many disk required tu adalah, kalau kita gunakan RAID 6, kita akan buat N tambah dengan 2N. Okay, N tambah dengan, bukan N tambah 2 disk. N tambah dengan 2 disk. Macam tu. Okay, so kalau lah katakan kita ada 1, 2, 3, 4. So, kena tambah 2. Okay. So, the advantage is that it provides extremely high data availability. Disebabkan kita ada two type of parity. Okay, so each of this parity will check, okay, cross out any differences lah. Okay, so that's why dia kata yang ni lagi kita kata macam high data availability. Okay, so 3Ds would have to fail within the mean time to repair interval to cause the data to be lost. Okay, so on the other hand, RAID 6 incurs a substantial write penalty because each write affects 2 parity block. So disadvantage dia adalah dia punya writing tu, okay, so one adalah pada data block, and then pada 2 parity block. So P dan Q tu nanti. So itu adalah antara dia punya disadvantage dia lah kalau menggunakan RAID level 6, which is more complex for a controller design. Okay, disebabkan calculation tu tadi kan. So, RAID level 6 ni perfect solution for mission critical application. Okay.